Hello, this is Physics 2212, lab number 2, Lines of Charge. Brief introduction. So the purpose of this lab was to perform an additional analysis on the floating tape system observed in the first lab. In this lab, the floating tape was treated as a line of charge, and its total charge was calculated and used to computationally determine the total electric force acting upon it. So what were some of the models and fundamental physics principles we used? Well, we used a Python program and GLOW script to determine the total electric field and electric force on a piece of tape modeled as line charge. As for physics principles, we use Newton's second law to understand what the forces acting upon the top piece of tape or the floating piece of tape were when it was at rest or stationary. We also use Coulomb's law to figure out what the electric force was on the top piece of tape when it was stationary. We also use the force of gravity near the surface of Earth, which is derived from the general formula for gravitation. This was used to determine the magnitude of force of gravity on the top piece of tape when it was floating, or at all times in general. And on the bottom here is a preview of our results. And so how did we get to these results? Well, first we had to determine the total charge of Q, and this was done by equating the force of gravity to the electric force since the tape was at rest. So these forces should be equal, and the electric force was equal to the charge of the total charge of the top tape times the electric field of a line or a rod. And in doing so, we were able to isolate Q and solve for it. And then we use this value in the computational model that we created. We also use these other constants as can be seen here. And then we created a function that would return the electric field when we inputted the charge of the source in the observation location. There's also this function right here, which kind of created a number of point charges in a line that would be modeled as the tape. These bottom lines of code here kind of depicted the line charges of the top and bottom tape. Moving on, these nested for loops were created to determine the electric field for a point charge on the top piece of tape caused by each point charge on the bottom piece of tape. This was done for every point charge on the top piece of tape in an iterative process. So we were able to get the electric field at each point charge on the top piece of tape. And so lastly, these bottom lines of code right here kind of helped us create an arrow that depicted the magnitude of the electric force on the top piece of tape as well as the gravitational force on the top piece of tape. So when we ran this code, we got this visual and these results right here. So what we're seeing here, the green arrows kind of represent the electric field at each point charge on the top piece of tape. The white arrow represents the electric force, the yellow arrow represents the gravitational force, and the red line right here is the top tape, and the blue line is the bottom tape. So what we got when we ran this code was that the net electric force acting on the floating piece of tape was 1.738 times 10 to the negative 3 newtons. The gravitational force acting on it, which was also able to be calculated manually, was 1.962 times 10 to the negative 3 newtons. So discussion, additional questions, and conclusions. So the final results, as we just discussed, we did see a slight disparity. This could be attributed to the fact that we did not account for any other possible forces, like a friction force that kind of helped keep the tape up, or any such air resistance, or stuff like that. And the assumptions we had to make to obtain these results were that we had to ignore air resistance. We had to assume that each tape had about the same amount of charge evenly distributed along its length. And some possible sources that could have affected these results, well, tape was, we modeled the tape with a relatively small number of point charges, 40 in this case. We also used some rounded values in calculations. The chances of these things affecting our result are little to none. So, additional questions. So, to answer the what if question, the Q we got in the point charge model was 1.3 times 10 to the negative 8. The Q in the line charge model was 2.51 times 10 to the negative 8. So, why do these estimates differ? Which value is more likely to be closer to the real value? Well, these estimates differ because the charge is being measured over varying distances. This could be a likely explanation. And nonetheless, the Q in the line charge is more likely to be accurate as a piece of tape more closely resembles a line charge rather than a single condensed point charge. So in conclusion, the total charge on the piece of tape model as a line charge was determined to be 2.51 times 10 to the negative 8 coulombs. Using this value, an electric force of 1.738 times 10 to the negative 3 newtons was computationally determined and compared to the magnitude of the gravitational force on the piece of tape. which is calculated to be 1.962 times 10 to the negative 3 newtons. This clear discrepancy could be attributed to the fact that the tape is not a perfect line of charge, and we did not account for other forces or air resistance and such things. And as such, we also assumed, as said, we assumed the tape was a perfect line of charge. And so this could have caused some discrepancy seen. Thank you.